Today we are going to start with a new concept, that is refraction of light. So before refraction of light, I want to recall or say the difference between reflection and refraction. Let's recall what is reflection and how it is different from refraction. In case of reflection, we know that there is this is a surface, reflecting surface, a ray of incident, it comes and falls on the reflecting surface. This is a normal is imaginary line which is perpendicular to the reflecting surface, and after reflection the reflected ray, it bounces back into the same medium. So this is the incident ray, this one is the incident ray. The incident ray, after striking the reflecting surface, it bounces back into the same medium. This is the reflected ray, it bounces back into the same medium. So this is reflection, where the ray of light, it bounces back into the same medium and there is no change in speed. There is no change in the speed of light, no change in the speed of light, and also there is no bending takes place. So here what happens, the ray of light, after getting reflected, it bounces back into the same medium. The speed, there is no change in the speed and there is no change in the medium, it bounces back to the same medium. Now what is refraction? Refraction is, say what is refraction. In case of refraction, there is two medium is considered. Okay, suppose this is number 1, medium number 1, this is medium number 2, and this straight line, this one is a surface which separates these two medium. So when a ray of light, it strikes the surface, say for example I am drawing normal over here. Normal is an imaginary line which is perpendicular to the surface. When a ray of light, it strikes the surface, after refraction, what happens when the light, it travels from one medium to another medium, the speed changes. So light travels at different speed in different media. Light, it travels at different speed in different media. So when the ray of light strikes the surface and it has to go through another medium, its speed changes, and as the speed changes, the bending of light rays takes place. So this change of path or bending of light ray is known as refraction. So what happens, the light ray, it changes the original path, it get bent, the path changes. So the original path was this. If it doesn't undergo any kind of bending, then the original path was this was the original path. But due to refraction, bending of light rays takes place. So when light travels from one medium to another medium, what happens, due to difference in speed takes place. Why difference in speed takes place, I will explain just after some time. So when there is a difference of speed is there, what happens, bending of light rays takes place. The light ray, they change their path, they change their speed, they change their path, they bend. So this is known as refraction. So if we go straight to the definition of refraction, what is refraction? Refraction is when light travels from one transparent medium to another transparent medium. When light travels from one transparent medium to another transparent medium, it bends from the original path. It bends from its original path. It bends from its original path. And this phenomena is known as refraction of light. So when light travels from one transparent medium to another transparent medium, it bends from its original path, and that is called refraction. Now the question arises, how this bending takes place and why there is a change in the speed of light. Let's have a look on that. For that we have to come across two topic, that is optically rarer medium and optically denser medium. Optically rarer medium and optically denser medium. What does that mean? Optically rarer and optically denser. Suppose let's take this one. The molecules, where the molecules are very closely packed. The molecules where it is very closely packed and there is hardly any space or there is very little space in the molecule. Where it is very closely packed, the molecules are very tightly packed. What happens? The speed of light decreases. Let's take an example. When you are walking in a crowded road, naturally your natural pace, your original pace will decrease. When you are walking in a road which is full of people, crowded, so naturally your pace, your walking speed will decrease. Same happen in case of light ray. When light rays strike a surface where strike a medium or strike a surface where the particles are very closely packed, the speed of light decreases. That is the optically denser medium. Optically denser medium is something where the molecules or particles are very closely packed, and as a result of which the speed of light decreases. Okay, what is an optically rarer medium? Optically rarer medium, take for an example a media where particles are present in a gap. There are moderate gaps present. You take an example when you are walking in a road where there is not so many people in the road. It's an empty, or you can walk with your own pace. You can walk very fast through that road. Same in case of optically rarer medium. The light rays, when they strikes an optically rarer medium, the speed increases. Why? Because the particles or the molecules present in the optically rarer medium, they are far apart from each other. So the light get to move with a very high speed. So in optically denser medium, the speed of light decreases. It decreases in optically denser medium, and speed of light it increases in optically rarer medium. Okay, now I have to draw the diagram once again. Suppose this is the interface. I am taking an optically rarer medium and this is an optically denser medium. The light ray is coming from an optically rarer medium. Okay, the incident light is coming from an optically rarer medium, and it strikes this refracting surface. We have to draw the normal over here. After reflection, when the ray of light travels from optically rarer to optically denser medium, mind it, optically rarer medium is the one where it is not much more crowded, and optically denser medium is a crowded one. So when the ray of light it travels from optically rarer medium and it enters into an optically denser medium, what happens? Bending of light rays will take place due to refraction, and here the ray of light it moves towards the normal. What happens? The ray of light it moves towards the normal. So when a ray of light is moving from optically rarer medium to optically denser medium, it moves towards the normal. It moves towards the normal. Okay, so this is my angle of incidence, this is my angle of refraction. So what is the angle of refraction? Angle of refraction is the angle between the refracted ray. This one is the refracted ray, this is a refracted ray. So the angle between the refracted ray and the normal is give me angle of refraction. So angle of refraction is the angle between the refracted ray and the normal. It gives angle of refraction. What is angle of incidence? The angle between the incident ray and the normal. This one is the incident ray and this is the normal. I have already mentioned n above the normal. Normal is the imaginary straight line drawn over the surface, perpendicular to the surface of refraction. So when the ray of light, it travels from optically rarer to denser medium, the ray of light, after refraction, it moves towards the normal. Okay, now see what happens when the ray of light travels from denser medium to rarer medium. When the ray of light travels from denser to rarer medium, what happens? This is the denser medium, this is the rarer medium. Okay, so when a ray of light which is incident, the incident ray of light is in the denser medium, this is the normal. When the ray of light travels from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. It bends away from the normal. From the normal. So this is your incident ray and this one is the refracted ray. Always remember, the refracted ray is the the angle of refraction is the angle between the refracted ray and the normal. This is the refracted ray, this is the normal. So the angle between the refracted ray and the normal gives me the angle of refraction. And in case of denser to rarer medium, the refracted ray, it moves away from the normal. Clear? Okay, now let's take an example, and not an example, another case. So in that case, suppose this is a denser medium, this is a rarer medium. When a ray of light, it passes from one medium to another medium and it is passing through the normal. When the ray of light, it passes through the normal, that means when the ray of light, it passes from one medium to another medium at right angle to the surface separating the two media. What happens when it is passing through the normal? It refracts back into the original path, original direction. In this case, the angle of incidence is 0 and angle of refraction is also 0. So when the ray of light is traveling, be it from denser medium to rarer medium or from rarer medium to denser medium, doesn't matter. Be it from denser medium to rarer medium or rarer to denser medium, doesn't matter. When a ray of light travels through normal, it gets refracted back to the original path. So angle of incidence is 0, angle of refraction will also be 0. Then let's recollect what we have learned so far. We have learned about what is refraction, and I told that refraction is the bending of light rays takes place when light travels from one media to another media. Okay, what happens when light ray travels from rarer medium to denser medium? When the light ray travels from rarer medium to denser medium, this is the normal. They move after refraction, the refracted ray, they move towards the normal. They move towards the normal, towards the normal. Okay, and what happens when a ray of light, it moves from denser medium to rarer medium? This is the denser medium, this one is a denser medium, a ray of light coming from denser medium, this is normal. After refraction, it bends away from the normal, it bends away from the normal. Here it is angle of incidence, this one is angle of diffraction, this one is angle of incidence, this one is angle of diffraction. Another case, it bends away, it bends away from normal. And the last case is when the ray of light, it be it a denser medium, rarer medium, or this one is rarer or this one is denser, when the ray of light, it travels through the normal, after refraction it gets refracted to its original path. These are the three cases. Over here angle I is equal to 0, angle R is also equal to 0. Okay, now let's talk about the laws of refraction. What are the laws of refraction? Laws of refraction. The refraction light obeys the two law. Refraction of light, it obeys the two law. What are the two laws? The incident ray, the first one is the incident ray, the refracted ray, incident ray, refracted ray, and normal at the point of incidence, at the point of incidence, all lie in the same plane, all lie in the same plane. This is the first law of refraction. What is the second law of refraction? Second law of refraction, for a given pair of media, the ratio of sine of angle I to the sine of angle R is always constant. So over here sine I, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and this constant is denoted by a symbol of mu. So the second law, this second law is known as Snell's law. Here the constant, this constant, that is mu, it is known as refractive index. This is the refractive index. Let's look much in detail. So let's recollect once again. What are the two laws of refraction? The incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane. And for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. That is, sine I divided by sine R is constant, and the constant term is denoted by the symbol, this is mu. And this second law is known as Snell's law. It is known as Snell's law.